So in this quick video, I want to talk about the intrinsic pathway of coagulation as well as the extrinsic pathway. Now let me get you oriented to the image that you're seeing here. What I'm using is a damaged blood vessel to talk about what happens in the coagulation process. So what we have here is the inside of a blood vessel, the blood vessel lumen. So we're only seeing part of the blood vessel. And down here we have the blood vessel wall, and then there's going to be some collagen fibers that are anchoring this to some tissue cells. So this is our orientation here. So one of the things that has to happen is we have to have an injury to the blood vessel wall. So let's create that. Okay, so we've sustained some injury to our blood vessel wall. We can see it's disrupted. And one of the things that's going to happen is you're going to have collagen fibers that are exposed. Now the body in its wisdom knows that collagen fibers are supposed to be in a certain place. And it also knows that cell parts are supposed to be inside the cell. So when it detects that there are exposed collagen fibers and that there are cell parts all strewn about, it knows that there's been damage to that area. And you're going to see a cascade of chemicals rushing to that area, triggering a number of events. Now we're just going to be looking at the triggering events that are going to cause a clot to form. So we're going to just look at for the moment at the exposed collagen fibers, because this is what's going to be important to us. So these collagen fibers are going to be doing two things. One of the things that it's going to be doing is it's going to be triggering the intrinsic pathway, which means these exposed collagen fibers are going to take an inactive form of one of the clotting chemicals needed in the cascade of clotting chemicals that's already floating around in the blood. It's going to take factor 12, which when it's in the blood normally without any injury to the blood vessel wall, it's going to be inactive. These collagen fibers are going to activate factor 12 and now make them active. And that's an important event in the intrinsic pathway. Now the other thing that's going to happen with these exposed collagen fibers is that it's going to make our platelet cells sticky, and it's going to cause the platelet cells to congregate here and start to form that platelet plug. So that's what the exposed collagen is doing. It's activating the intrinsic pathway, causing factor 12 to become active, and it's going to create it's going to cause the platelet cells to become sticky and start to congregate there. Now let's take a look at the extrinsic pathway. So the other event that's going to happen at this site of damage is that some of these cells are going to release tissue factors. Now what are tissue factors going to do? Well, they're also going to take a chemical that's normally floating around in our blood that's inactive, one of the clotting chemicals that we're going to need as part of this cascade. It's going to take factor 7, and it's going to convert it from its inactive form to its active form. So this is what the extrinsic pathway is doing. Basically, it's creating the scenario where we're going to activate factor 7 as part of the clotting cascade, and intrinsic pathway is going to trigger the activation of factor 12. Now let's see what's important about these two things on the next slide. So as we just saw on the previous slide, the extrinsic pathway is going to give us an active form of factor 7, and the intrinsic pathway is going to give us an active form of factor 12. Now, why are these two of importance to us? Because there's a lot of things going on. But these two are important because when these two become active, they're going to activate another factor called factor 10. I know it looks like an X, but it's the Roman numeral 10. So here's yet another one of those inactive factors floating around in the blood that is now activated. Now, why is factor 10 important? Well, it represents the point where the intrinsic pathway and the extrinsic pathway join to form a common pathway that's going to lead to the creation of that blood clot, that thrombus. So what is factor 10 doing for us? Well, it's seeking out this molecule known as prothrombin. And prothrombin is also inactive until it's acted on by factor 10, and then it becomes the active form known as thrombin. So factor 10 is activating prothrombin to make it become thrombin. Thrombin is important because it's going to seek out the inactive form of fibrin known as fibrinogen, and it's going to convert it into its active form. So thrombin is going to activate fibrinogen into fibrin, and fibrin is going to be what shows up at the injury site where those platelets are, and it's going to form that fibrin net that's going to be the component that leads to the formation of the thrombus. So we can see on this slide the contribution of the extrinsic pathway as well as the intrinsic pathway, and sequentially what's happening in order to get to that fibrin net that's going to create our clot.